Fs achieves its maximum value. Fs max is equal to mu s n. Therefore, tan theta is equal to mu s, or theta equal to tan inverse minus mu s. When theta becomes just a little more than theta max, there is a small net force on the block and it begins to slide. Note that theta max depends only on mu s and is independent of the mass of the block. For theta max is equal to 15 degree, mu s is equal to tan 15 degree, or is equal to 0.27. A body like a ring or a sphere rolling without slipping over a horizontal plane will suffer no friction. In principle, at every instant, there is just one point of contact between the body and the plane, and this point has no motion relative to the plane. In this ideal situation, kinetic or static friction is zero, and the body should continue to roll with constant velocity. We know in practice this will not happen, and some resistance to motion rolling friction does occur. That is, to keep the body rolling, some applied force is needed. For the same weight, rolling friction is much smaller, even by 2 or 3 orders of magnitude, than static or sliding friction. This is the reason why discovery of the wheel has been a major milestone in human history. Rolling friction again has a complex origin, though somewhat different from that of static and sliding friction. During rolling, the surfaces in contact get momentarily deformed a little, and this results in a finite area, not a point, of the body being in contact with the surface. The, the net effect is that the component of the contact force parallel to the surface opposes motion. We often regard friction as something undesirable. In many situations, like in a machine with different moving parts, friction does have a negative role. It opposes relative motion and thereby di- dissipates power in the form of heat, etc. Lubricants are a way of reducing kinetic friction in a machine. Another way is to use ball bearings between two moving parts of a machine. Since the rolling friction between ball bearings and the surface in contact is very small, power dissipation is reduced. A thin cushion of air maintained between solid surface in relative motion is another effective way of reducing friction. In many practical situations, however, friction is critically needed. Kinetic friction that dissipates power is nevertheless important for quickly stopping relative motion. It is made use of by brakes in machines and automobiles. Similarly, static friction is important in daily life. We are able to walk because of friction. It is impossible of a car to move on a very slippery road. On an ordinary road, the friction between the tires and the road provides the necessary external force to accelerate the car. Thank you.